I couldn't in college.
Change that, and send me an email.
Okay, thank you.
Yeah, okay. Change that and send me an email right now. I mean, after class. Okay, let us start. Now, the topics that we have today, really, I'm not going to ask you any. You must see them, but I'm not going to ask you any problems from these topics on the first exam, on exam 1, which we are having next week, right? But you should see them, because the reason is it is about solving equations and finding inverse of 3 by 3 matrix, etc. But you already know how to do that. You know how to use Cramer's rule. You know how to use, so, but you should see this. So here is a problem. So okay, I will write this later, but let us do this. Solve the system. Now solve the system using row operations, elementary row operations. So say for something like this, x1, you just see this once and then we don't have to worry about this. Okay, so what you do, you form the augmented, this is called the augmented matrix, form the augmented matrix. What's the augmented matrix? So you take the coefficient matrix 1, 1, 2, 2, 4, minus 3, 3, 6, minus 5, and then take the this one 9, 1, 0. The name of the game is this. I want to reduce everything to, listen to me carefully, I'm going to and see how my pen here. I want to reduce everything to this form. This will be a 0, this will be a 0. This will be a 0, this will be a 0. This will be a 0, this will be a 0. So only the diagonal will exist. And how to do that? Using row operations, which you know very well, row operations. So let's do this. So I want to make this 0, so you know what to do, right? And I want to make this 0, okay? So you have 1, 1, 2, 9. Multiply the first row by minus 2, add it to the second row. 0, minus 2, 4 minus 2 is 2, minus 2, that is minus 4, minus 3, minus 7, minus 2, minus 18, plus 1, minus 17. Multiply the first row by minus 3, add to the third row, 0, minus 3. 6 minus 3, 3, minus 3, minus 6, minus 5, minus 11, minus 3, minus 27, okay. Okay, now I want to make, this is fine, I want to make this, I want to make, the idea is I want to make this 2 should go away. I want to make this 1.
Hi, we did multiply row 2 with 3, no, row 1 with negative 3.
No, first multiply first row by negative 2, add it to the second row.
Okay.
Then multiply first row by negative 3, add it to the third row.
Okay, got it.
Okay, so this is what you get. And now I want to make this guy 1. I want to make this guy 0. So, okay, so what do? You multiply by half, isn't it? So,
Professor, if you don't mind, can you write the row reductions on the side, like what you did, like multiplying rows?
Yeah, that would be help. That's what I was asking too.
Yeah, because when we review it, I totally don't forget it, like how we did it.
no, that's very complicated. Overall, especially here, and that is very kind of spoon feeding. Listen, multiplying the first row by -2, add it to the second row, and you get this. Multiply the first row by -3, add it to the third row, and you get this.
Yes, I understand, but I just wanted, like, if you could write this thing on the side, it could be there.
Then there is a 2 here. I want to multiply by half. I want to get this into 1. So 1, 1, 2, 9, 0, 1. I'm multiplying by half. -7 upon 2, -17 upon 2. I multiply this by, okay, no, don't do it together simultaneously. That is problematic. Okay, I now multiply this by, I multiply by, okay, no, don't do that. How about multiplying this by 0, 1 minus 17, 0. No, wait a second. There is a problem here. I multiplied by -3, added it to this. Good, -3, right. Just a minute. Okay, I want to make this 0. Oh, there is a very easy way to do that. Good, since this is 0. Multiply the second row, here it is. So look at my ink, my pen. Multiply the second row by -3. Add it to the third row. So that becomes, don't disturb the first row. Multiply this by -3, add it to the okay, -3. So this is 21 upon 2 minus 3 times, so 21 upon 2 minus 11. So that becomes what? Minus half. So I'm multiplying this by the second row by -3. So -3 times -17 is 51. 51 upon 2 minus 27. -3 by 2. Okay, I'm almost there. All I need to do is I want to make this 0, this guy. So I'm done with the second row, third row. I'm happy with all that. I want to make this 0. So that's easy. How do you do that? Tell me, how do you do that?
I'm sorry, Professor. I'm a bit late. What are we looking for?
I want to make this 0. This one 0. Okay, that's easy. Multiply the second row by -1. Don't disturb the second row. Multiply the second row by -1. Add it to the first row. That's it, 0. So my -1. So this is 7 upon 2 plus 2. 7 upon 2 plus 2. 7 plus 4. 11 upon 2. By -1, that is 17 upon 2 plus 9. 17 upon 2 plus 9. 35 by 2. Now 17 plus 17 upon 2 plus 9. Yeah, right. So that's what you have. So what's actually going on here? So once you have this situation, here it is. You can get the equations like this. Oh, I want to make this guy 0. This is fine. This is 0, 1, this 0, 0. This is the goal. The goal is, let me write this, 1, 0, 0, 0, 1, 0, 0, 0, 1, blah, 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 blah. That's the goal. This is where I want to reach. Okay? So how will I make this guy? I want to make...
Professor, I'm sorry. In this matrix, are you talking about the upper matrix or
What?
because can you write again why what you just erased? Just to show you something. What you just erased, can you write it again? The matrix you just erased. Yes.
This is the goal.
Okay, the second, I think the second,
Okay. That's fine. We will talk about that later.
okay.
So now let's continue. Okay, mute yourself, please. All right, I want to make this, first of all, okay, this is fine. This is, multiply the third row by, we don't like these fractions, right? Multiply the third row by -2. Then this is 1, then this is 3. Okay, now you see you're almost there. All I need to do is I need to just take care of this guy. This I want to make 0. Okay, this is easy. This is easy. No, don't disturb that. Keep the second row as it is. Just a minute. Okay, keep the second row, third row. Multiply the third row by -11 upon 2. Add it to the first row. So I'm multiplying this row by -11 upon 2. So this is 0. No, this is 1. Why should I make that 0? This is 1. I multiply this by -11 upon 2. Can you just hold on just a minute? Hello? Oh, yeah, hi. This is Mr. Mitra. I just sent you an email. Mhm. Yes, yes. I will get all my reports next week, or either this weekend or early next week. But I had a conversation with Dr. Bayako this afternoon, and he asked me to see you. Hmm. But the same one, GHI, but I will show you the new, bring the new card. Yeah, GHI. Okay, so not this Monday, how about 19th or 21st? Excellent. At 2:30. And can you just reply to my email with your address so that, yeah, please, please. No cancel, no cancel. It's very important. Now I'm feeling like I had a big major surgery. I will tell you everything. Yeah, okay. 19 to 2:30. Very good. Thank you. And I please reply to my email so that I can get I can note it down 19th to 30 and also and your address. Thank you. Thank you. Thank you. Bye. Okay, I'm sorry about that. This was an important call. I'm multiplying the third row by minus 11 upon 2, adding it to the first row, so that naturally becomes 0, minus 11 upon 2 multiplied by 3. So minus 11 upon 2 multiplied by 3, minus 33 by 2. Add it to the first row. So plus 35 by 2. Oh, how that's nice. 2 upon 2, that is 1. Finally, I want to get this guy 0. So that's easy. Just multiply it by. No. No. Multiply the third row by 7 upon 2, add it to the second row. Multiply this by 7 upon 2. No, this is 1. Why am I disturbing this? 7 upon 2, good. Multiply this by 7 upon 2. 7 upon 2 times 3, 21 upon 2, minus 17 upon 2, 4 upon 2, so that is 2. Okay, you know what's the meaning of this? I don't understand, these people come so late. Okay, now what's the meaning of this? So, now I can read off everything clearly from here. X1 is equal to, so this will give you the answers. X1 equal to 1. X2 is equal to 2. X3 is equal to 3.
Is this row reduction echelon?
This is the row reduction business. Now I'm not going to give you any problem on this. You just want to see this, that's all. Because you see why? Because you have Cramer's rule, and I am going to give you a problem by Cramer's rule.
Professor, is it x1 2? Negative
X1
3.
is equal to 1, X2 is equal to 2, X3 equal to 3.
Oh.
Yeah.
Oh, all right. Oh, I see why.
Yeah.
All right.
I don't know whether it was X1, X2. Yeah, X1, X2, yes. Good. So this is the idea of, so, there is a word for this, and let me just tell you this word. How do I get this? This is called, because later on we will need this is called row echelon. No, where is this? Yeah. So these are called row echelon matrices. When you see something like this, say row echelon, so the idea of row echelon is this. So the leading term is 1, 0, 0, 4, say. Then just after 1, there will be a 0. Then there is 1, 0, 7. Then after these two, there will be 0, 0, like this 1, -1, whatever you write. This is called reduced row echelon. So that means the element, the leading term will be 1, and the elements after just below 1 will 0, then below the 1 is 0, 0, like that. So that is one thing, but we are not interested in. So that's one thing, and I'm not going to ask you any question on this, but you must see that once. Let me show you something called Gauss-Jordan elimination.
So, Professor, you're never going to ask this type of question?
No. There's no point.
That's good. I mean, because they take so long.
Yeah, I know. And there is no point because I'm going to ask you a problem on Cramer's rule, right? And you can solve this system by Cramer's rule, right? This is what you have done. It's much better to solve this.
That's easier.
Yeah, you do it by Cramer's rule, but you must see this later on. And this is called, what we are going to do now is called Gauss-Jordan elimination. The idea is the same. Idea is very much the same. Okay, now let me take a good one so that you will get a nice solution. Pum, 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 pum. Oh. Yeah. So let me take just one problem, Gauss-Jordan elimination. You must see it once. See it once in case we need it later. I won't ask you any problem on the exam. That's the question. So these are called, okay, let me show you what's a row echelon form. So this is 1. So this one, you see, 4, -3, 7, 0, 1, 6, 2, 0, 0, 1, 5. This is row echelon. Why row echelon? Because this is not 0. But this is reduced row echelon. Where something like this, say 1, 0, 0, 4, 5, 0, 1, 0, 7, 0, 0, 1, 9. This is reduced row echelon. Let me just show you one Gauss-Jordan, that's all. But again, I'm not going to ask any problem on the exam. But you should see once. Take something like this. It's kind of fun. Use Gauss-Jordan elimination to solve the the linear system here. So you say something like this, say x1 plus 3x2 minus 2x3 plus 2x5. When I put a gap, that means x4 is 0 there, 0. 2x1 plus 6x2 minus 5x3 minus 2x4 plus 4x5 minus 3x6 is 0. 5x3 plus 10x4 plus 15x6 is 0. 2x1 plus 6x2 plus 8x4 plus 4x5 plus 18x6 is 0. Okay, so see what's happening. What's the matrix? So the matrix is 1, 3, minus 2, 0, 2. Remember there's a 6 here, x6, so therefore 0. And what are the right hand, the coefficients here on the right hand column? That's 0. So similarly, 2, 6, minus 5, minus 2, 4, minus 3, 0, and 0, 0, 5, 10, 0, 15, 0, 2, 6, 0, 8, 4, 18, 0. So our goal is to exactly as I said, I mean, just we have to reduce it to, but this is very easy. I have to reduce it to this one. So you see, I can do it right away here. 1, okay, wait a second. Yes, everything is fine. Good. So here's the augmented matrix. Augmented matrix means you add this column that's there. Okay, so I want to. Okay, so let's start. 1, 3, minus 2, 0, 2, 0, 0. I want to make this 0. I want to make this 0. That's very easy. Multiply the first row by minus 2, add it to the second row. So 0, minus 2, that is minus 6 plus 6, 0, minus 2, minus 2, no? Minus 2, so 4 minus 5, 1, minus 1, 2, minus 2, 2, 0. 0, 0, 5, 10, 0, 15, 0. Multiplying now again by the first row by minus 2, add it to the fourth row. Minus 2 times minus 2, 4. Minus 2 times 2 is minus 4. Okay. then what do? I just multiply the second row by just one, that's all. By -1, because I want to change the sign.
What's the goal here?
I'm showing you. The goal is like this. I will try to make it in the row echelon, reduced row echelon form. So 0, 0, multiplied by -1. So this 1, 2, 0, 3, 0, 0, 0, 5, 10, 0, 15, 0, 0, 0, 4, 8, 0, 18, 0. I'm almost there, you see? Now what
So making one diagonally and everything else is 0.
Yeah. Now what do you do? So 1, 3, good. 0, 1, right. So I want to, okay, good. I want to make this 0. I want to make this 0. See, I want to make this 0, this 0. So that's again very simple. Do not disturb your first row at all. Multiply the second row by -5, add it to the third row. -5 added to the third row. Multiply the second row by -4, added to the fourth row. By -4, -12. So this is what we have got. And I can easily take it like this. Now, why am I getting... Why am I getting this to be 0? Wait. Oh, this, how did I get this to be? 1, 3, wait a second. That's why I don't want to... Oh, this is a different question. Okay, this is a different question anyway. Okay, it doesn't matter now. I can simply write this. So what do I get from here? I get x1 plus 3x2 minus 2x3. There's no x4 plus 2x5 is 0. x3 plus 2x4 plus 3x5 is 0. 6x6 is 0. So you see, that means what? x6 is 0. Okay, x6 is 0, that's fine. And there are a couple of matters here.
Second equation It's 3 plus 3x6. Second row.
Very good. Thank you. Excellent. Good observation. And therefore, I get x3 plus 2x4 is 0. So that means what? That means x4 is minus x3 by 2. So x3 is anything. So I get this one. So x1 is minus 3x2 minus 2x3 plus 2x minus minus 2x5.
You mean plus 2x3?
x1 equal to minus 3x2 minus 2x3 plus 2x3, thank you, minus 2x5. And I have x3, or rather, yeah, and x4 is minus x3 by 2. And x5, x6 is 0. So, and you can choose a value for x3, you get some x4 and all that stuff. So this is just Gauss-Jordan elimination. I'm not going to give you any, ask you any problems on this. So, because on Tuesday I don't want to discuss anything on the exam, I want to give you the exam material today thoroughly, so that you will be, because Tuesday I want to start with vector spaces. I told you that, very important, the really important topic. Okay, exam 1, math 231. I want to talk about the exam now. Exam 1. I gave you the material, but let me make it clear. And when is it? Thursday. And that is October 15th. So the class starts at 1:40. So let me start at 1:50. Class ends at 3:10, 3 p.m. Okay, let me go back to what I sent you. Please, just a minute. Sent. Just a minute, please. Okay, here. So this is okay. This disgusting. Okay, good. Two problems on eigenvalues. Now, I said one question on Thursday in the material. No. Then one problem on orthogonal matrices. One problem, one question. One question on Cramer's rule. One question on finding the inverse of a 3 by 3 matrix, on finding A inverse using adjoint where A is a 3 by 3 matrix. One question on evaluating a 4 by 4 determinant. By row reduction. Good. And then by row reduction, so let me see how many. 1, 2, 3, 4, plus 2, 6. Okay. And one question. So I will ask you to, I will definitely ask you to prove. So there will be proofs. So one question on theorems. On theorem, I'm going to tell you, I'll give you a list of theorems. So one will be if A is invertible, prove that A transpose is invertible and A transpose inverse is A inverse transpose. I think we did it last time also. This is one. Just a minute. These I did, but I must remind you. You must prepare 4 theorems, that's enough. Yeah, here it is. Here it is. So this is one theorem. 2, prove that the transpose of an orthogonal matrix is orthogonal.
Professor?
Wait, prove that, just a minute, I will take all questions, just a minute. Prove that the inverse of an orthogonal matrix is orthogonal. I want 3, 4. Prove that. No, okay, put it this way. If A and B are orthogonal, matrices prove that A times B is orthogonal. Number 5, if A is orthogonal, prove that determinant of A is plus or minus 1. Okay, question. So out of these 5, just out of this 5, 2 questions on proofs. Yeah, question?
You answered it already. Thank you.
I've already answered. Okay, good. That's it. That is it. Next, some instructions. Yes, please.
For number 4, is that if A plus B or if A
If
and B?
A and B, okay? Yeah, I will choose any 2 questions from that 5. So you prepare all 5. So you don't have to choose it, right? I will choose it. I will make the choice for you, okay? Now some instructions. Good.
Professor, can you scroll back up a little?
I will. Just a minute. I will do everything. Just a minute. Let me write this down first. Okay. Is this okay? Should I go down or scroll down or up?
A little bit upper, please, Professor. I just want to see the questions that's on the test. Yes, thank you.
Copy this. Take your time. Ready?
Professor,
Yeah.
during the last lecture, you said you will ask us to find a inverse, but not, required, using adjoint. We can use any method.
No, you don't have to do that. Just using adjoint. Using adjoint. That's very complicated, that method. It's the one that I wanted to. Okay, ready. Now, what I'm going to give you is very important. Okay. Important instructions. Because I found something was not correct on the quiz, and you better check it now. Number 1, write your full name. On the first page. Write your full name on the first page. You don't have to write on all pages. Number 2, the exam will be proctored. This you guys did fairly well. And so each of you, each student should be visible on the screen for the entire exam. Do not copy the questions. Only number them. So each student must have a clear video camera. This is most important. Please submit your exam by email no later than 3:15 p.m. on that day, of course. And how are we going to do that? This is the most important part. As a single, as one PDF file as follows: your name dot PDF. Okay? Any questions? So 2 proofs and these computations, and there maybe there's 1 or 2. That's it. That's basically, I just want to tell you the one thing. Hello. Yeah, just to recall, you have seen this many times. What's a symmetric matrix? What's a skew symmetric matrix? Come on. Hello, tell me what's a symmetric matrix. I'm not writing anything. You tell me what is a symmetric matrix.
A inverse equal A transpose?
No, not A inverse. My goodness, that's orthogonal.
A is equal to A transpose.
Huh?
A is equal to A transpose.
Very good. A equal to A transpose, yes. And what's a skew symmetric matrix? Tell me. You just told me what is the symmetric matrix. Why don't you tell me what's the skew symmetric matrix? Sure. Whatever.
Symmetric?
Huh?
Not symmetric? A is not equal to H.
No, skew symmetric. Hello? Come on. Hello. You know what's the symmetric matrix. Then you just told me what's the symmetric matrix. Now tell me what's the skew symmetric matrix.
When it equals the negative of the matrix,
No, what do you mean? What is equal to negative of a matrix? What kind of an answer is that? What will I understand from there? So, a square matrix is symmetric
Is it if A equal to A transpose?
if A is equal to A transpose. And a square matrix
Is Q symmetric if A transpose equal to minus A?
good. A square matrix is skew symmetric. Okay. Then you have some properties. So if A is symmetric, the following are obvious, then A transpose is symmetric. A and B, okay. Now, KA is symmetric if K is a scalar. Okay, so here is a question. Problem. Suppose A is symmetric. And invertible. Show that A inverse is symmetric. How will you do that? So A inverse transpose, we know, is A transpose inverse. But A is symmetric, so therefore A transpose is A. So A inverse. Hence, A inverse is symmetric. Do this problem, let's see. Find all values of A, B, C, D such that A is skew symmetric. Say A is This is kind of a review, so this is. Do it, let's see. Do it. So when I say here, just a minute, I wrote here 2 questions on eigenvalues or 1 question on eigenvalue and 1 question on no. Let me quickly this. 2 questions on eigenvalues I forgot about this. Or 1 question on eigenvalue and 1 question on symmetric skew symmetric matrices. Good. Do this problem. So A is skew symmetric. That means A transpose is equal to minus A. So what is A transpose? 0, 2A minus 3B plus C, 3A minus 5B plus 5C, minus 2, 0, 5A minus 8B plus 6C. Now, minus 3 minus 5B. And that is equal to minus A. So 0, minus 2A plus 3B minus C, minus 3A plus 5B minus 5C, 2, 0, minus 5A plus 8B minus 6C, 3, 5 minus D. So what do you get? You equate these two. So you get 2A minus 3B plus C is 2. 3A minus 5B plus 5C is 3. And D is A transpose. No. A transpose, what is A transpose? Okay. Third row became the third column. Okay, and D equal to minus D. D equal to minus D. Anything else? I said find A, B, C, D, na? Achha. Another one. Naturally, this one. Minus 5A plus 8B minus 6C is minus 5. Okay, D equal to minus D. This implies 2D is 0, and that implies D is 0. That's good. That's good news. Now, 3 equations, 3 unknowns. So 2A minus 3B plus C is 2. So why don't you multiply this? 3A minus 5B plus 5C is 3. Then 5A minus 8B plus 6C is 5. Okay. Why don't I multiply the first row by 5? So 10A minus 15B plus 5C is 10. 3A minus 5B plus 5C is 3. Subtract. Minus 10B and why don't I multiply the first row by 6? Subtract. Oh, same thing. I'm getting the same thing. No. So that means I have So I have to. Now that's how to solve this ABC. You have to solve this ABC, no? So why don't we do this? I'm going to ask you a problem on Cramer's rule. Let's have a practice. Come on. Let's have a practice for Cramer's rule, isn't it? Just for fun. So A is, don't say A, call it X, but something. Don't, because if it is A, then so that call it X. So now A is this, and here is a good practice. 2 minus 3, 1, 3, minus 5, 5, 5, minus 8, 6. What's the determinant of A? Minus 30, minus 40, 10. Plus minus. 18 minus 25 minus 7 plus minus 24 minus 25 minus 24 plus 25. Huh? Oh my goodness, determinant is 0, so you cannot solve. Did I get the right numbers? No, then you cannot solve. So something is wrong somewhere. 0, 2a minus 3b plus 3a minus 5b plus 5c minus 2, 0, 5a minus 8b plus 6c minus 3 minus 5d. Yes. So X transpose 0, 5a minus 8b plus 6c minus 3 minus 5d. Okay. Yes. So 2a minus 3b plus c is 2. 3a minus 5b plus 5c is 3. So no, so then that means you cannot solve. Not ABC, the values ABC don't exist. So I think it should be symmetric. If you can, okay, why don't we do this? Find all values of, no. Then D will be indeterminate. No. So you cannot get the answer. The determinant is 0. Isn't it? Can we just check it? That's fine. 2 times minus 30 minus 40. That's right. Plus minus 3. 18 minus 25. Yes. Plus minus plus. Minus 24 minus 25. Minus 24 plus 25. Yes. 20 minus 21 plus 1. No. So ABC, D is 0, ABC not determined. System cannot be solved. Or else you can get infinitely many solutions. Let me show you something, by the way. Wait. You cannot solve it this by Cramer's rule, but yes. So as I was doing this, so if I multiply this equation, I did it actually. If I multiply the first equation by 5, what do I get? So let me write. Yeah, I have it. So by 5, 10a, because it cannot be determined. So 10a minus 5b, 15. 10a minus 15b plus 5c is 2. 3a minus 5b plus 5c is 3. It cannot be 2. It cannot be multiplied by 5. So it's 10. Okay, subtract. 7a minus 10b is 7. So 7a is equal to 10b plus 7. So a is equal to 10 upon 7, b plus 1. And now go to choose any of these equations. Choose the third equation, 5a minus 8b. So 5a minus 8b plus 6c plus 6c is 5. So 6c is 5 minus 5a plus 8b. So that is 5 minus 5. A is 10 upon 7, b plus 1 plus 8b. So that gives me 5 minus 50 upon 7. Now, I will never give you a problem like this on the exam, minus 5 plus 8b. So 5 minus 5, oh, wonderful. 5 minus 5 cancels. So what do you get? This is 7, 8, 56, no? 7, 8, 56. 56 minus 5, 6. 6 upon 7, b. So that means C is b upon 7. So here is your answer. You get infinitely many values. D is 0. C is b upon 7. A is 10 upon 7, b plus 1. And b, anything, any value. So you get infinitely many values. So I'm not going to ask you a problem like this, certainly not. But how about this one? How about how about this one? Prove that every square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. So A is a square matrix. I can write A to be A half A plus A transpose plus A minus A transpose. So A plus A transpose is symmetric because A plus A transpose is A transpose plus A transpose transpose, that is A. So that's the same. And A minus A transpose is skew symmetric. Why? Because A minus A transpose is A transpose minus A transpose transpose A. That is minus of A minus A transpose. So that's the. So how about this one? Problem. Suppose A is skew symmetric, is an invertible skew symmetric matrix. Show that A inverse is skew symmetric. So A is an invertible skew symmetric matrix. So A transpose equal to minus A. So A inverse transpose is A transpose inverse. So that is minus A inverse. So that is minus 1, that is, so the scalar goes out, A inverse. Hence, A transpose A inverse is skew symmetric. Let's do one last problem and then that's enough of review. Problem. If A transpose A is equal to A, show that A is symmetric. And A is equal to A squared. That means A times A. How will you do that? Let's see. So I want to show that A is symmetric. No? So, yeah, if A is symmetric, then it is easy. Okay, I see. So A transpose A is A. That implies A transpose A transpose is A transpose. That implies A transpose transpose A is A transpose. This is 1, this is 2. From 1 and 2, we get A equal to A transpose. Hence, A is symmetric. And A transpose A equal to A will imply A transpose is A times A is A. That implies A squared is A. Proved. Okay, so that's basically it. I'm going to give you some office hours. In case you need. Tuesday, October 13, 5 p.m. to 6 p.m. That's it. I have nothing more to say today. That's enough. Any questions? But remember, Tuesday we start with the vector spaces. So no excuse, do not miss class. The Tuesday's material will not be included on exam 1, no question about that. But do not miss that. If you miss the first day, you will never be able to recover. You will never be able to recover. Believe me, it's so damn important. Okay? Any other questions?
Okay, thank you, Professor.
Thank you. I'm going to send everything to you. I'm ending the meeting.
Thank you.
Amit Charan, please send me an email so that I can get back to you. I will send you the notes. Okay, thank you very much. Have a nice weekend, and we will meet on Tuesday for vector spaces. Very important. The center of gravity of the course. Thank you.
Thank you, Professor.